Hi, this video is to present our CHI 2020 paper titled Questioning the AI, Informing Design Practices for Explainable AI User Experiences. My name is Vera Liao. I'm a researcher working at IBM Research. This is joint work with my colleagues Dan Gruen and Sarah Miller. Artificial intelligence technology, especially those using machine learning, are increasingly used everywhere, including high-stakes tasks such as supporting decision-making in healthcare, finance, and social justice. Accompanying this trend is a quest for explainable AI, that is, making AI more transparent and understandable by people. So people can feel more confident or better exercise caution with AI's decisions and ultimately better work and live together with AI. But explainable AI is hard. It involves a lot of technical work. There are many different machine learning algorithms, and not all are straightforward explainable. It is also commonly recognized that popular high-performing algorithms, such as those using neural networks, are especially complex, opaque, and almost impossible to explain in their working directly. So often a separate set of techniques or algorithms have to be used to generate explanations that can be consumed by people. Developing this technique is the main focus of the research field Explainable AI, or XAI, which started as a subfield of AI research. These are just some recent review papers on the topic. There are at a scale of hundreds, if not more papers published on the topic. Another noticeable trend is that very recently, a growing number of toolkits are making these XAI techniques accessible for practitioners. So we are seeing explanations becoming an instrumental part and likely increasing so in real-world AI systems. Explainable AI is also hard because explanation has to be meaningful to the people demanding it. Simply exposing a model's inner working does not guarantee the information is understandable or useful to the users. There are also many different types of users who may have different reasons and requirements to seek explanations. So creating explainable AI systems should follow a user-centered process to bridge technical capabilities and fulfillment of user needs. In product practices, this kind of work often falls on design and user experience practitioners, whose job involves identifying user needs, communicating with data scientists, developers, and stakeholders, and creating design solutions based on demands and constraints on both sides. Therefore, in this work, we look into the design practices around the current and upcoming explainable AI technologies. Our goal is to identify opportunities to better support such work, hence the creation of user-centered explainable AI. By talking to design practitioners across many AI products, we also hope to understand real-world user needs for explainable AI and the design space, which could help inform future direction for the research field of XAI. But very quickly, we ran into the challenge of how to talk about the technical space that people are not quite in there yet, since we just began introducing what's produced in the academic world to practitioners. Our informants may not be familiar with different XAI algorithms or have an established framework to talk about user needs for explainability. So we decided to create a study probe, a list of algorithm-informed XAI questions. The probe is based on the following assumptions. First, user needs for explainability can be represented by prototypical questions such as why, what if, how. This is both based on prior work on explaining computing systems and fundamentally the definition that explanation is an answer to a question. We also assume that a prototypical questions can be answered by one or multiple XAI methods, which can be implemented by one or multiple XAI algorithms. The key idea here is that even though there are hundreds of XAI algorithms, many of them produce the same kind of output or method to explain. So there is a much more finite list of XAI methods. For example, a why question asking about a particular AI decision can be explained by a popular method called local feature importance, which highlights the most important features of the instance that contributed to the AI's decision. In this case, pixels that the image classifier used to determine this is a wolf by mistake. Meanwhile, there are many popular algorithms to implement this local feature importance method. Based on this reasoning, we started with a literature review of technical XAI work and arrived at a taxonomy of explanation methods. Then we mapped them to a total of 6 categories of prototypical questions, such as why, what if, how. We also decided to take a broad view of explainable AI and added 3 more descriptive categories of questions based on prior work. These are questions regarding AI's input, output, and performance. For each category of the prototypical question, we created a question card. It includes the leading question and common examples. Then we brought these question cards to the informants. In total, we interviewed 20 design practitioners working on 16 different AI products. In each interview, we asked the informants to first walk through the AI system, then discuss what are the common questions users might ask to understand the AI. After that, we worked through each question card and discussed whether they apply, and if there are any missing questions. We closed the interviews by discussing what are the challenges the design practitioners and their team face to create explainable AI systems. Through step 2 and step 3, we gathered a list of user questions. We performed content analysis on these questions, details in the paper. The outcome, and one of the main contributions of the paper, is this XAI question bank. It includes both the algorithm-informed questions we started with and new questions identified from the interviews marked by asterisks. This question bank represents a quote-to-quote designer source space of user needs for AI explainability. It also helped grounding our discussions to understand these questions in real-world context. We'll come back to the question bank later and talk more about its functions. But first, I want to discuss the main themes identified in the interview analysis. They point to the challenges for design practitioners to create explainable AI user experience. The first challenge the designers face is the variability of users' explainability needs. First of all, there are diverse motivations for people to demand explanations. We summarize 5 main categories with more details in the paper. For example, some users demand explanation to gain further insights for their decisions. As the example given by this informant, it was not enough for the AI to give a prediction to supply chain management workers that a delivery might be delayed. More importantly, users want to understand the reason for the potential delay, whether it is because of the weather or somewhere they could make a quick call to. So they can take actions based on the explanations. In this context, users may ask a why question, why the delivery is predicted to be late, and how to reduce the delay. A different motivation for demanding explanation is to appropriately evaluate the capability of the AI. For example, when a doctor is introduced to a new AI system for medical imaging, the doctor may want to understand both how well the system performs and how the system makes its judgment. These are 2 out of the 5 types of motivation we identified. We also identified other factors mentioned by the informants that could vary users' explainability needs, including user group, usage points, algorithm and data type, and the decision context. A second challenge that we saw informants struggle with is the gaps between explanation as a common element in human communication and what current AI technology can produce. They mentioned some common criteria of human explanations. That's what users might expect to see, such as being selective, contrastive, interactive, and tailored for the recipients. However, it is often not possible to generate AI explanation that satisfy these criteria, both constrained by current technical capabilities and the inherent discrepancy between how human and AI makes decisions. Lastly, informants discussed some process-oriented challenges for AI product teams to invest on or prioritize explainability. One challenge is for designers to navigate the technical capabilities to explain AI, partly due to the skill gaps, and also it is challenging to keep track of the quickly growing landscape of XAI. There are also barriers for designers to effectively communicate with data scientists and other stakeholders around explainability. Even though explainable AI solutions should be jointly sought from user perspective and modeling perspective. This communication cost combined with prototyping costs to explore design solution often discourage AI product team to prioritize explainability, which could be at odds with other product goals. Many believe that these problems can be mitigated by having structured guidance that help the team efficiently navigate to desired explainability solutions. We summarize the desired support in two areas. One is to support the needs specification work. What are the explainability needs specific to a product, a user group, even a particular interaction? Second is after needs specification, guidelines or recommendation to address the needs, ideally with example artifacts such as model output or UI patterns to save the prototyping cost. You may consider two areas as answering what to explain and how to explain respectively. Now, coming back to the XAI question bank, we suggest that this list of prototypical user questions can be leveraged for needs specification work, whether as a checklist or in user research to enumerate on and prioritize different types of user needs for AI explainability, for example, through a card sorting exercise. In our paper, the question bank and informant's discussion around it also serve two other functions, which I will not go into detail by pointing you to the paper. One is to ground our understanding on why these use questions are asked in real-world context. Based on that, we derive a set of guidelines to address each categories of user needs for explainability. Second, understanding where these questions emerge, especially the newly identified questions that were not in the algorithm-informed question list, will identify gaps in current technical work of XAI and opportunities for future work. Back to tackling the process-oriented challenges. At the end of the paper, we propose a question-driven design process that centers the design of explainable AI around user questions. We suggest that from user research to identify key user questions for understanding AI, and also the requirements to answer these questions. Then work with data scientists to map these questions to candidate XAI techniques that could answer these questions. Starting from what these techniques produce, iteratively design and evaluate the explainable AI user experience against the user requirements. Besides providing an XAI question bank to support identifying key user questions, the kind of mapping we did in the beginning, from user questions to XAI methods and algorithm, can be used to suggest candidate solutions to the data scientists. Essentially, this process allows user questions to become the boundary objects to support joint discussions between designers and data scientists. As follow-up work for this paper, we're currently practicing and validating this question-driven design process with the AI teams, and we hope to share the results in the near future. I want to thank you for viewing this presentation. To summarize, our CHI'2020 paper, by interviewing 20 AI design practitioners, set out to understand real-world user needs for 9 categories of AI explainability. We produce insights to address them and inform opportunities for future XAI work. We also identified key challenges faced by design practitioners to create explainable AI user experiences. To help tackle these challenges, we suggest the XAI question bank and a question-driven design process. I would like to invite you to read our paper, and I'll be happy to answer your question and hear any feedback you have. Thank you for your time and attention.